Hello, my name is Naim Awan bin Ahmad Zakri. This is my data structures project for SWC3684. I developed a pirate crew mission management system using a linked list, queue, and stack in Java. I worked on this project alone, so I handled the entire design, coding, and documentation myself. So before that, let's look at the table of contents. So first, some introduction. Second is the IPO chart. Third is the UML class diagrams. The fourth one is the flowchart. Of course, the sample data and output, and also the source code snippets. The what are some lessons learned, reflections, some references, the visual presentation link, and the GitHub repository link. Okay, so let's move on to the introduction. So this project is a pilot crew mission management system developed for the SWC3684 data structures course. The main objective is to demonstrate how to use multiple data structures, specifically a linked list, queue, and stack, to manage, organize, and process pirate mission data efficiently. The system reads a .txt file containing 100 lines of pirate mission information, groups mission under each pirate using a linked list, assigns pirates to route-based queues for batch processing, and finally pushes complete pirates to a stack for last in, first out display. This project helped me understand how to design and implement practical data structures operation while applying software design tools like IPO charts, UML diagrams, and flowcharts. Moving on to the IPO chart. So here is my IPO chart. It explains how the system works. The input is a .txt file containing 100 lines of pirate mission data, the one piece underscore combine.txt file. It contains 100 lines of pirate mission data. The process involves reading each line, creating crew member info objects, and grouping missions using a linked list. After that, pirates are assigned to different queues based on the number of missions, and then processed in batches of 5. Finally, completed pirates are pushed to a stack and displayed in last in first out order. The output is a group list of pirates with their missions, queue summaries, and the stack display. So let's move on to the UML class diagram. So the UMS class diagrams shows, this is my UMS class diagram. It shows that crew member info has a list of mission info. So this is aggregation. Pirate queue manager manages the three queues, the East Blue, South Blue, and Grand Line. Pirate Mission Processor, on the other hand, handles the batch processing and pushes pirates to the stack for final display. So let's move on to the flowchart. This is my flowchart, shows the entire process. So it starts and by reading the one piece underscore combine text file, and it's in create or update crew member info in a linked list, and then it route pirates to queues based on mission count. It processes each queue in first out batches of 5, and then finally it pushes complete pirates to the stack. Finally, pop pirates from the stack to display them in a last in first out order. So let's move on to the sample data. So this is some sample data from the one piece underscore combined text. So before that, let us first look at my code snippets. So this is my crew member info class. It has attributes for ID, name, pirate crew, and list of missions. The add mission method shows how missions are grouped for each pirate using a linked list. In Pirate Queue Manager, on the other hand, this assign queue method shows how pirates are routed to East Blue, South Blue, or Grand Line based on mission counts. In Pirate Mission Processor, this process mission method shows how the program processes queues in first in, first out order and pushes pirates to the stack for final last in first out display. So let us now look at the output. So let's run the program back. Wait, close this. Okay. So as you can see, when I run the program, you can see the console output shows the crew list grouped by pirate with total bounty of each. The queue summary shows which pirates were routed to each sea, and then the stack output confirms that the pirates were pushed and popped correctly, showing the last in and first out order. So now let's move on to some of the lessons that I learned or some short reflection. So since I did this project alone, of course it was a difficult experience because I had to monitor every detail of the development cycle, from acquiring a grasp of the problem, developing data flow using linked list, queue, and stack, right through to writing down the logic and debugging it. One of the most valuable lessons learned was the necessity to design the structure prior to coding. The process of developing the UML and IPO diagrams made me understand how the data would flow through each step in the system. I also became more confidently advanced in using Java collection, especially on how to apply queue and stack in real life situations like batch processing and last in first out processing of jobs. Having done everything on my own required problem solving, endurance, and time management. I feel more comfortable now solving complex problems and recording my work in a professional manner. This project didn't just test my programming expertise, it also taught me how to deliver an entire solution from start to finish, just like real software projects. So that's all from me. Thank you for watching my presentation. You can find my source code and report on GitHub. So that is all from me. Thank you.